Hello everybody. So today we are going to be starting with the first programming project, and with the idea is that we are going to try to introduce programming concepts kind of in a different way than you're used to. And the way that we're going to be doing that, we're going to try at least, is we are not going to start with the very basics of the programming language Java, which we use. What we're going to do is we're going to kind of like motivate it in a different approach. And that approach is to actually have a real world programming problem, which is going to involve many different concepts, some of which are, I guess, quote unquote basic, and some are high level. And the idea is that we are going to, when they become relevant for the context of our problem, then we're going to be introducing some of the programming concepts. This is a re-recording of, this is a recording from, or I'm taking inspiration from the first programming class that I had that only Jalen was involved in. And hopefully this will, one, consolidate and all of the information there in a nice and accessible way. So let's get started. And we're going to get started with some motivation. So something that Team 4 wants to do is we want to have Swerve drive on our robot. So we're currently procuring and putting together the Swerve modules, and the idea is that now programmers need to program this thing. So this programming exercise that we're going to do is very relates directly to Swerve drive, but more importantly, it's applicable and it's relevant to all different types of components in the programming world. So for example, a manipulator, an elevator, an arm, all can use the code that we're developing. Okay, so let's just get started and kind of motivate this for a little bit. Can I do full screen somehow? Whatever. Okay, so with Swerve drive, how would us as the well, first of all, let's go back. Swerve drive is essentially a drivetrain that has 4 independent motors and wheels. So, sorry, 4 independent Swerve modules, one at each corner of the robot. And the idea is that a Swerve drive can spin each of these wheels in a certain direction, turn it to a specific angle, and it can also provide the wheel, turn the wheel so it can actually go front or back, or both ways, both directions. So the idea is that depending on the angles that you set the wheels at and the speed that you set the wheels at, you can get some very cool behavior with the robot. So if, for example, you have all the wheels pointed in the same direction, and the length of this arrow represents kind of the speed or the magnitude or the speed of the wheel. If they're all pointed in the same direction with the same speed, your robot is going to translate. So can you see my? Hold on. Yes. What's going on? Yeah, so the robot is going to translate without spinning. So this is kind of like the omnidirectional capability that Swerve drive enables. So, however, if you do something interesting, which is orient the wheels at, let's say, a 90-degree angle to one another, and they're spinning at the same speed, or the wheels are turning at the same angular velocity, then you're going to get a rotation. So your robot is going to rotate. And so those can be done by West Coast Drive. The strafing, you can only go forward and backwards. But what happens if you combine these together? So in the third picture, you have the wheels kind of not oriented in the same way, but in different ways. And you can see that the speeds of the different wheels or the wheel modules are different. So this wheel is going super fast, and this wheel's turn is going super slow. And you can kind of get an interesting a combination of a translation, which is this straight arrow, and a rotation. Hold on. Sorry about that. And so what you can get is swerve behavior such as this. So this is Team 1717, who was one of the pioneers of Swerve Drive. So you can see that the robot is going forward while also rotating, and this can be done in that manner by strategically setting the angle at which the modules are and the speeds of that. And this is essentially Swerve Drive. Okay, pretty cool. And now you can get some other behavior, which I will speak about now, and we can see how to do this in the code. So what they're doing is actually, if we go back to the diagram here, we can see that we can set the center of rotation to be anywhere. So you know, by default we want when the robot rotates, it should rotate about the center of its axis, or the center of its geometry. But you can, for example, change that and pivot around a wheel. So you can see that it's pivoting around this wheel, and you can change that. So that's something else that we can do. Okay, so that's essentially the idea. So now what we're going to do is, this seems to be a very difficult problem, and in a lot of ways it is, but in a lot of ways it's not. So what we can do as software engineers or software developers or programmers, all kind of the same thing. 1 second. Is we break it down into steps. So the robot acts according to steps. So what I've done here is I have broken this down, the Swerve Drive problem, into different steps. So the first step is to tell the software or the code, or write in the code, where the Swerve modules are. So what we're going to do is we are going to have to tell the program from the center from where we want to rotate. This is like in the coordinate system 0, 0. How far to the right and how far up is this first module up here? Can you see my, yeah, you can. So how far, in what position is this upper right module? Alternatively, where is the lower right module? And the back and the lower left and the upper left. And so the first step in terms of to be able to do Swerve Drive is you have to tell the software where the Swerve modules are. And this is actually what we're going to be programming. There is kind of a concept that that first, or WPILib, which is their official supported library, supports, called the Translation2d object, which is basically a mechanism to be able to specify X and Y locations programmatically. So essentially, it's going to support go to the X 1 foot or 20 inches, and go up 30 inches, something like that. So the first step is to tell the software where the Swerve modules are. After you've done that, then you can the software can set up the Swerve Drive logic. And that's essentially, that takes the desired it takes the desired modules that you want to control, and it basically like sets up all of the logic to be able to spit out or to output kind of the angles of each wheel and the speed of each wheel. So that's the second step, and that's kind of the black magic of Swerve Drive. And we're not going to get into that right now, but what we could do in a later video or later lecture is we can actually start to unpack that if you'd like. And it's pretty cool how Swerve Drive, how this actual logic works. So that's the second step. And the third step is you basically tell the software or the Swerve logic module how fast do you want to go in the X direction, in the Y direction, and how much do you want it to spin? And you can think of this as a command or a signal that's sent by the controller. So you have a controller. If you go on the left joystick, you go up and to the right. That translates to an X kind of speed in the X direction, a speed in the Y direction. And then you can think of another joystick controlling the rotation. So you can have something like that. So step 3 is to tell the software how you want the robot to move in all 3 directions. Again, you have 3 independent axes with Swerve Drive. You have the X axis, the Y axis, and then the rotation axis. And then what this module that we set up in step 2 is going to tell you is it's going to output what are the angles and speeds of each of these wheels. And so you can think of problems. You can take a complex problem like Swerve Drive, and you can break it up into steps 1, 2, 3, and 4. And so this is actually coming from the WPI libs documentation. And they basically have a pre-built solution, which we're going to be leveraging, and we're going to actually take this as an example and start to peel it apart and see how WPI lib actually implements these things. So you can see the code here, and but I also copied it over here, and it looks pretty cool in this program. It looks like handwriting. So again, let's take a step back. And our code, and again, this is for a lot of you, this is the first time seeing codes. This might seem intimidating, but really, like, we're going to break it down into steps. We really want to logically understand and have nothing be like black magic. So number 1, tell the software where the Swerve modules are. As I alluded to before, we need to specify the X and the Y location of these modules, and how of these Swerve Drive modules. And how we do that in the code is we have kind of a piece of code called a Translation2d object, and we'll get into what an object is later. So what you can see here just from the name is front left location. So essentially what this is it's saying, well, the front left location over here, we are specifying the location, so the X and the Y coordinates of that. And you can see here, and we'll get into all this syntax, is that it's 0.381 on the X and 0.381 on the Y. And you can see that both of them are positive. Well, that doesn't make any sense. Maybe I can copy this over here. Nice, okay. Cool. Okay, so you see that both the X and the Y are positive, but this is the front left module. So all that means is we're defining the axes to be like this. So the X and the Y axis, again, this is the positive X axis and the positive Y axis. So we're just setting the positive X axis to be going to the left, and as long as you're consistent, it does not matter. So you can see here that the front left location, maybe I can do this, is specifying where this module is. And the front right location, which is On the x-axis, 0.381. So on the x-axis, 0.381. And then on the y-axis, it's going down to minus 0.381. So I guess this right here is that. So I guess terminology is a little confusing, but this makes sense. The back left is minus on the x and plus on the y. So that's this one, and this is minus minus, that's this one. So you can see here that all this is doing here is it's just specifying, it's stating to the code where each of the modules are. Because you might intuitively understand that if the robot was smaller, so the position of these modules were kind of like this, then the output commands to the motors would be different. And you can see something else here, just from this code over here that's given to us. Each of these numbers are the same number, and the only thing that changes is the sign. So what this is saying is this is the configuration for a robot with this size, so 0.381 times 2, I guess, horizontally and vertically, and this is a square robot. So in the case that you have more of a rectangular robot, you would just change the x and y position of these modules, and that's how you would account for a different geometry robot. Okay, so that's that. Now going back to the steps, right? We're trying to follow the steps that we laid out logically, right? There's no code in here, but this is kind of logical steps that we need to follow. So so that's number one. We told the software where the Swerve modules are. The next step is to set up the Swerve logic. And so this is provided by WPILib. And this is let's just treat this right now as a black box. It is an object which you pass into it, right? You have to tell the software where the Swerve modules are. So you can see in these parentheses, and we'll get to the logic later, you pass into the code each of the locations of the Swerve drive. So you can see you pass in all 4. And so now the third step is to tell the software how you want the robot to move in all 3 directions. Again, we've defined, I guess, our coordinate system where going to the left is x and going up is y. Oh, I see what it is. I see why it's a little confusing. It's because in WPILib, they call up the vertical direction x and the horizontal direction y. So let's just remap this for a second. I'm not sure why they do that, but they're fine to do that. So this is positive, positive. So positive, positive. So that's this one. That's still a little weird. Oh, so I guess what they do, sorry about that, is they define their axes like this. Hold on. And let's just confirm that. Hold on. Kinematics, is it here? No. No. Where is it? Software. Translation2d. Where would that be? Advanced controls? No, path planning probably. Let's see. System. Yeah, let's see. No. Translation2d. Transformations. I think it's like right here. Geometry classes. Coordinate systems. Great. Okay, so it seems like, whatever, there's, I guess it's a little weird, but fine. So, but for this to be the front left location, and for both of these to be positive, that would be that. The front right is positive on the X, which is up, and negative on the, yeah. Okay, so that's that. Minus is down, and Y to the right. So that's this one and this one. But again, what this is showing is it doesn't matter what your coordinate system is, as long as you're consistent. So number 3 is to tell the software how you want to move in all 3 directions. And so what you do is you, there's another kind of object called chassis speed, where you pass in how far or how fast you want to move in the X direction, or on the X-axis, the Y-axis, and then the rotation. So you'll see example chassis speed. You want to go 1 meter per second forward. That's this X, which makes sense that this X positive is forward. 3 meters per second to the left. So 3 to the left, and that makes sense because we've defined Y to be positive in the left direction. And rotation at 1.5 radians per second, which is an angular velocity. So what you've done is you told the software, I want the robot to move in this with these speeds. And then what you do is with the black magic is the 4th step is this black magic here will spit out the speeds, the angle and the speed of each one of your modules. And so we've broken this down into how Swerve Drive works from a top level point of view. And so now what we're going to do is we are going to start to actually write code that could be used for Swerve Drive, even though we may not have much experience. And we are going to write our own implementation of Translation2d. Okay, so perfect. Okay, so what we're going to be doing is let's talk about what this Translation2d thing should do. I'm going to copy this here. And when I was teaching Jalen, he asked a very important question, which is, this looks like magic to us. It's like, what does all this even mean? And so we're gonna break it down, okay? So we can see here, let's just analyze this string right here. So we see, and let's kind of like match and pattern, let's like kind of create some patterns or identify some things that, let's look at this and kind of see what we can understand. So we see the name of the thing. So the name of this thing is, so we see that we have some sort of name here that we can set for ourselves. It can be anything. So we have the name of the thing. We also have the name of the type. So this front left location has a certain type. What is it exactly? It is what we call a Translation2d, and that can be anything that we call it, that we want to call it. And it's the name of the type. What is the M front left location? It is a Translation2d thing. Okay. So now what we're gonna do is we are going to this. Okay, so we're gonna now look at the right side of the equals, and we are gonna say what are, so we see there's like parentheses, so maybe I can say parentheses. So we see parentheses here, and maybe I like these arrows, they're pretty cool. So we have parentheses here, and you'll see a comma here. Oh, let me just arrow. So we see a comma over here. And so we have two different things that we're passing into it. You see there's this 0.381, and then after the comma, there's another 0.381. And as I showed you over here, these correspond to the X and the Y positions. So I'm gonna say this is the X and this is the Y. So just by kind of like looking at this string or looking at this text here, you'll see that this is actually an instruction to the computer or to the program with many different things going on. And you'll see that the same pattern occurs over and over again. So we have the name of the type here and over here. We have the name of the thing, which is over here. And then we have parentheses, and inside we can have parameters which we can send in. So there's two of them. And you can see that same thing happens over here with this Swerve drive kinematics. So again, the name of the thing is M kinematics. The name of the type you see over here and over here. You can see parentheses, and you can see different things that we're passing in separated by commas. It happens again and again. It's over here, chassis speed. There's the name of the thing, or the type. This is the name of the thing, we call it speed. So whenever we want to reference it, we can call speed. So you see it over here. We have this new word, which is across all of them. And then we have the name of the thing again, parentheses, and then comma separated arguments. Okay, so I'm showing you, as I said in the beginning, what I want to do is, even though it seems very complicated what we're going over, I want you to start to see patterns and recognize that when you see one thing and you learn one thing, it might be very complicated at first, but once you understand it, then it's going to start to get much simpler. Oh no, okay, so you can't, I'm going to go to this view. Okay. Or maybe actually yeah, this is fine. I just can't go below this area. Okay, that's fine. So this is an explanation of what this text is doing. And so now we are going to better understand this. We're going to graphically understand. Maybe I can bring it up here because this is right here. That's better. I don't know. Hopefully this will work. And I just can't go above there. Okay, so what we're going to do is we're going to take this and put some more technical terminology. Okay. So what we have is, hold on. Okay, class objects. Okay, so this right here is called a class. Okay, so this Translation2d thing is called a class. And we are going to try to understand what is a class. So over here we have text. So a class. And this is a class with a name called Translation2d. Okay. Here, let's do this. Translation2d. Okay, without bringing any technical terminology into it. So what is this supposed to do? So this is kind of like an embodiment of some sort of logic. So what is it supposed to do? It should know the x and y positions that I give it. Okay. Maybe I can. What? How do I? Okay. So the Translation2d thing should know the x and y positions that I give it. So inside of a class, so this is called a class, okay? And this is kind of like just a description. So the description of what this class should do is that it should know the x and y positions that I give it. The next thing it should do is it should help me if I need to do some sort of operation to it. So for example, I think I should maybe make this bigger. Maybe not. Okay. So what are some things that I can do to it? So for example, what happens if I want to add 2 points together? And we'll talk about what that means. Or if I want to what did I? Yes. I'm so sorry. So we are going to take a detour and explain not what this Translation2d thing is doing, but give a better example. So let's think of a person, okay? So what is a person? A person, how do you define a person? A person can be defined by different attributes. So the example that I gave was, what are some attributes that a person can have? So some of the attributes are, and can you see this? Yeah, you can. Okay. So some of the attributes that a person can have are things such as they can have a height. Another thing that a person can have, and again, this is not an individual person, it's a person in a general sense. They all have certain attributes. They have a height, they have a weight, they have, let's say, an age. And you can go down the list of different attributes that a person can has. Okay. So let's say, okay, so given these attributes, right, of height, weight, and age, if I know somebody's, let's say, height and their weight, something, I can ask things about this person if I know their height, their weight, and their age. Something that I can ask them is, and these are called methods, and we'll get to that in a minute, is we can ask them what is their BMI. And BMI is defined as, I don't know, it's some sort of weight over height or something like that. So I can, if I know their height and their weight, and I remember that, I can ask this person, what is your BMI? Even though if it's nice or not, that's a different story. But you can take these two attributes, they're called, or properties, and you can ask what their BMI is. And this is called a method. This is, more specifically, it's called like a function or a method. And what is their BMI? So this right here, this BMI uses uses some of these attributes. What are the attributes that it uses? It depends on the height and it depends on the weight. This is a little bit, so it depends on the height and it depends on the weight. And so given these two attributes, we can compute their BMI. In code, if you were to do this, you would say, it would look something like this. Double get BMI, something like this. And let's analyze this in a little bit more scrutiny. Okay. So this, we can see here some similarity to what we did earlier. So this is get BMI. So this is the name of the function. And you see that there's parentheses. And so you see this thing in front. And again, going back, you can see over here, this is the name of the thing. And this is a name that goes in front, or the name of the type. Okay, so going back to the get BMI example, this is a get BMI, and the type is called double. And what is a double? Double is a decimal number. So it can represent any decimal number. For example, example 1.2, 2.0, 4.5, and so on. So it's a decimal number. So this get BMI then looks into its internal attributes or properties, and it can do some sort of logic. It can take the height and the weight and divide them, or whatever the formula is. What are some other properties that you can ask about this person if you know their height, their weight, and their age? Let's say is over 18, right? So you can say, are they over 18? And that is, again, this right here is the name of the function or the method. You have parentheses, which actually executes the code that you write. And what you need in front of it is, what is the data type, or what is the type? And in this case, is over 18 is a true or false value. Either you are over 18 or you're under. And that's called a Boolean. So this is something else. This is another method that you can ask about. Can I do that? Yeah, nice. This is another thing that you can ask about this person if you know the height, the weight, or the age. And is over 18, this references what property? It just references the age. So you can see here that if you create a person class and you provide it with these attributes, height, weight, or age, it's kind of like a container where you can ask certain things about this person. So in the code, so that's the first thing. But the second thing is that, as you can see here, this does not describe a particular person, right? It describes kind of a class, or it's a description of what a person is. And on the other hand, you have what's known as an object. And an object references a person, a class. So this object is of type person. So for example, if I were to execute this in the code, and let's say I'm gonna create a specific person, which is me, let's say. I'm gonna write person, Adam, is equal to new person. So let's take a step back. This person, the first thing we write, again, is the name of the type. And in this example, the type is a person type. So that's the first thing that I write. I write person. The next thing that I write is the name of the thing, or the name of the object. So instead of thing, you can say the technical term is object. So I'm going to name this object Adam, because that's me. Then I put in equals in this new thing. And then you can see that I have to repeat the name of the class here. So it's new person. And then I put the parentheses and semicolon at the end. And the semicolon is just, you just have to add it. So this now describes the Adam person. But you can see here that in order to fully describe the person, we need to provide the height, the weight, and the age. And so that's what these arguments, the things inside these parentheses, are called arguments. And this is the data that you pass into the person object. So the first thing, maybe I want to start by putting my age, my weight, and my, let's say, height, weight, and age. So if I do this, let's just put that up here. So let's say my height is 5 feet 11 inches in centimeters. Let's say it's in centimeters. Let's do 180. Okay, you can do it in feet or whatever, but it's a little more complicated. So 180 in centimeters. My weight is, I don't know, 185 pounds. And my age is 28. So this right here describes a person who has these properties. And now, what are some of the things that we can ask of this person? So again, those are called the methods or the functions. So we can do a Boolean, is over 18. How I would do that in the code is I would say Adam, because that's the name of the person, the specific person. You do dot, and then you can ask any one of these methods, is over 18. So is over 18. And what the code will do is it will look at this age property and say, true, he is over 18. So what happens if we want to do have another person? Well, we can do the same kind of thing. We can say person, I don't know, Steve. He's a little bit, let's say, he's 200 pounds, or 200, oh, that's in centimeters. He's a tall guy. Let's say he's super skinny, and let's say he's only 16. So now this Steve person, you can say is over 18, and it'll be false. So what you can see here is this is the very important part of this exercise, is there's a difference between a class, which is something you write once, which defines any person, what a person is, and what you can do, what you can ask of that person. And on the other side is an object. These are individual objects of this class. So you can see that Adam is a single instance of the person class, and Steve is another instance of this person class. And so you can see that you write a class, once, and an object is you can create many objects. So you can have as many objects as you want of this given class. And so that's the important part. So always think about class and object. Let's go back to the Swerve tribe example, because now that we know this class and object kind of thing, this code is starting to hopefully make a lot more sense. Let's go through it. Okay. So this, again, can you see? Yes, you can. So this Okay, so let's break this down. Translation2d is the class. As you can see, it's called many different times. And you can now see that this, hold on, this line right here creates one object. And the name of the object is front left location. Then here you have another object. Remember, it's the same type. The type is a Translation2d. And what we're going to be doing in this lecture is we're going to create the Translation2d class that has certain properties on it. Okay? So we have one object that's m front left location with certain parameters. And we have another object of the same class, Translation2d, with different parameters. Remember, they're different locations. And so same thing here. We have a third object and a fourth object. So what we've done here in step 1, remember going back to step 1 over here, is we created 4 distinct objects, all Translation2d class of the type Translation2d, that define the location of the Swerve drive modules. And so that's what we did up here. Now down here, it's the exact same thing. We have Swerve drive kinematics, which is the first thing. This is the class. This is the name of the class. So this right here defines another object called mkinematics. What type of object is it? It's a Swerve drive kinematics object. Kinematics basically is the geometry and all of the logic. That's just a name for it. But it's creating a new object. And what do you have to pass into it? Instead, in the person example, in order to define the person, we needed to pass in the height, the weight, and the age. For Swerve drive kinematics to work, you need to pass in 4 different locations of the different Swerve drive modules. And that's what this needs to operate. That's what this needs to work. So in total, up until here, we have 5 different objects. We have 4 objects which represent the location of the modules. And we have another object which is like a higher level abstraction, which does all of the kinematics. Okay. Again, it's the same thing, and that's what I want to impart on you, is that it's the same thing over and over again. Now we have a new object, and the name of the object is speeds. And what class is it? It's a chassis speed class. Okay, so we see that repeated again. And you can see we have the parentheses. And the things that we have to pass into it are the speeds. And in this case, we can have 3 speeds that we want. One is the speed in the vertical direction, or going over here in the positive x, or the x-axis, which is up and down. The y, which is sideways, which in Swerve drive you can set those independently because it can move, not just in one direction, but in both independently. And then we need the angular speed if you want the robot to be turning. And so again, we have another object here called speeds. And then if you see this kinematics dot to Swerve module states, what this is, what is kinematics? Well, it's an object that we defined up here. It's this of class type Swerve drive kinematics. And so you can see this dot, just like over here in the person example, we called Adam dot is over 18. So we defined in the class, which again is the blueprint for what a person is, we defined a method that we called is over 18. Same thing. In in this kinematics point of view, two swerve module states, which is the angle and the speed of each wheel swerve module, is this two swerve module states is a method defined in the swerve drive kinematics class. And so you can see here that this is now hopefully a little bit less confusing. We, again, sorry to repeat, but this is very important. We defined 4 objects over here, which gives you the locations of the swerve drive modules. We created an object called mkinematics to kind of like set up the kinematics. We have an object over here which defines the speeds that you want the robot to go in. And then you have the swerve drive, then you call a method on the kinematics object, which gives you back a list of your swerve module states. So what we're going to be doing is, now that we hopefully see this kind of analogy here, we're going to actually design the Translation2d class. And that is, I think, over here. So this is, okay, this is kind of the same discussion that I had earlier, or last time. And now we can see, let's see here. Okay. So what we're going to be doing is we are now going to design the Translation2d class. Okay, so the first thing is, what do we need to store as properties on here? Well, I mean, I guess it's already here. Anyway, so in order to define what a Translation2d object has, or to be able to act upon it, we need to pass in what the x value is and what the y value is. And from there, we can do many different things. What are some of the things or the methods that we can do to this Translation2d object? Well, one thing is we can just say, what's my x value and what's my y value? Again, that's stored as a property in the class, and we'll get to why that's important. And then there's different methods, and we'll go through them as we work, that you can perform. So with that being said, let's actually hop into the code a little bit. And I don't want to do that. Okay. So 1 second, I'm gonna pause just for a quick sec. Okay, so let's get into it. Okay, so can you see my screen? Yes, you can. What parts can you see? You can see everything. Okay, so now let's make the bridge again between this class and this object thing. And you'll see how it's very, there are many good analogies. Make sure this is recording. Yes, it is. Okay. So we can see here that this Translation2d, again, is the name of our class. And you can see, in order to do that in the code, you do class Translation2d. Very simple. Let's actually, so what I've done is, let me just get this working dot Gradle W build, is it? No, slash what's this? Let's just make sure that it works. And so what I've done is I've actually designed tests to, it's kind of like interactive. It's testing the behavior of all of these different methods. So we are going to go through each of these methods. So you'll see the first we're going to do is get x. So we are going to, let's go to test get x. We're gonna enable this test, and we'll see that this is now gonna fail because I've created a blank Translation2d class with nothing programmed yet into it. So of course this is gonna fail. So let's look at the end implementation. Okay. So this right here, as you can see, you should be very familiar with this logic on line 219, or this syntax. Again, Translation2d is the name of the class. The name of the Translation2d object that we're creating is T1. This new thing is just saying I want to create a new object. Again, I have to repeat this Translation2d class name. Here I have parentheses, and can you see this? Hold on. Yeah, you can see it, I think. Okay. So I'm passing into it two parameters, one being the x and one being the y. And over here is I'm calling T1. Watch, if I go over here and do T1, which is the name of the object, do dot, I have all of these things that I can ask of this Translation2d object. And the one we're going to do is get x. Okay? So logically, and ignore what this is doing. It's just if getX gives you 1, then it passes. If it gives you anything but 1, as you can see over here, it's gonna fail. Okay, so this Translation2d, when you ask it to give you the x value, it should return 1 because that's what its x value is. So let's actually see how to implement this. So I'm gonna go into here, and I'm gonna go into my getX method. So again, okay, so then, hold on. So here, define methods. Okay, so you have these, which are define constructors, and I'll go over what that is in just a second because it is important. So in a class, you essentially have 3 different sections. The first section at the top is where your private variables are. And what that is, in the example that we had earlier, is these properties. What happens is when I create this T1 object, I'm passing in 2 properties, one and the x and the y value. And so what I have to do is I have to remember what these values are. So this is essentially my memory of my private memory. Yeah, it's my private memory. What do I care about holding on to in my memory? Okay, then you have something called the constructor, which is very special, and I'll get to that in a second. And then you have the methods that you can act upon this Translation2d class. Okay, so what are the different methods? Oh, well, first, okay, so number 1 is the private variables. Number 2 is the constructors, and number 3 are all of the methods that you can perform. And again, what we're trying to do is we are trying to get this to pass. Okay, so the first thing we do is, where's the code? So logically, what this needs to do is it has to say, okay, you're giving me the x value and the y value. I need to remember those values so that later, if you ask me for what the x value should be, I can pull into my memory, pull from my memory what the x value is and give you the answer. So that's what we're gonna do. So when you call this function, or you create a new function, what happens is this constructor is called. Constructor has the same name. You can see it's the same name as this class over here. And so right when you call this, it's gonna run this function over here. And you can see in the parentheses, you're defining what arguments are being passed into this object. So an x and a y. So again, what I have to do is I have to remember what my x value is, because after this constructor is called, again, after I finish running and I go on to this line, if I didn't save into my own memory this x value and this y value, I'm not going to have this information for you in the first place. So that's where my private memory comes in, or the private variables come in. And so by default in 254 does this naming convention, which I like, is all private variables start with m underscore. You don't have to, it could just be x, but I'm gonna do m underscore. And so this, I'm not gonna define it what it is yet. And so this x is what data type is it? Again, it's a double because you want it to be able to store a 1, a 2, a 3, or a 1.123, or a 4.5 or whatever. And so any decimals are stored inside of a double. And again, I want to store this, well, okay, so first, this translation2d, what I want to do is I want to take this, whatever is passed in this first position, and I want to store it in memory. And the way to do that is just say m underscore x, which is defined, which is available to me after this constructor is called, is equal to x. So I just want to set my mx equal to x, so that anywhere else I can just say my x value is now stored in m underscore x. And now I can do the same for the y. So the y is going to be a double as well, and m underscore y. And then over here, I also want my translation2d object to be able to hold on to that value of y. So m underscore y is equal to y. And so now, remember, going back to test get x, after this constructor is called and this object is created, I now want to implement my get x. So right now the get x is just returning 0. It's a dummy value. So where exactly am I going to find what my x value is? Well, remember, I've created it over here to be my private memory of what's important. So all I have to do is return m underscore x. And now if I go and run this test, you can see that it passes. So again, to recap, what just happened? I created a new object. What is its name? T1. What is its type? It's of type translation2d. When I called this function here, this, remember, is the same name as the class. This is called the constructor. So the constructor, the name of the method here, the constructor is the same as the class. I pass in the things I care about, x and y. I declare what my private memory is, mx and my, and I store these for later use. Then in my get x, I just recall what my mx value was, and it works. So again, test and get y. I'm going to disable this test. And this is the way that I think that we as Team 4 should develop, is that maybe a mentor should write tests and then the students make them pass, even on the robot. Okay, so you can see it failed. Test get y failed. Remember, x is still passing. Test get y. So let's look at what this is doing. So this is creating an object called t1. Same parameters, but it's already been implemented, which is the great thing. Now all we have to do is go into how get y is defined. You can see that it's returning 0. So in this case, we recall what we set it to be, and that's in m_y. So it's the same thing. It's confusing at first, but it gets much simpler over time. So you can see both of those are passing. Now let's go on to a few more test plus. Let's go on to this first operation, or this first method. And this is kind of, hold on. And this is kind of the first method that is special, or is not kind of as simple as test get x or get y. So let's motivate what addition when it comes to points means. Okay, they're really vectors, but that's fine. So line. Let's motivate it in this manner. Let's do a line here. Okay, so let's say we have a point here. And a point here. Let's say this is at 2 and this is at 3. So let's say we want to add both of these points together. Again, it's only on the x-axis. I'm defining, for better or worse, that addition of the points 2 and 3 are nothing but taking the x components and adding them together. So in this case, it'll be 5. So what happens if now I bring it into the into 2D, and I have this as 2, 1, and have this point as 3, 3. So again, I'm just defining this point plus this point to be the addition of the x components, so still 5, and then you add the y components together, so this will be 4. And really what this is it's vector addition, but we're not really gonna delve into that too much. So this vector from the origin to this point, plus the vector from this origin to this point, is the vector like that. But you don't have to worry about that. Let's just think of points. Translation2d as being a point. So you can see that what this add function is returning is actually another point. So you can see that the type of that's returned from this add is a Translation2d, because that's what we call a point. So let's go back to WPIler, and let's go to test plus. Again, this is going to fail because we haven't implemented this plus over here. And so now let's actually implement it. So we want, if you have t1, which is an object with its x value at 1 and then its y at 2, and then t2 is another object at 3, 4, you want t1 plus t2 to be, well, you add the x's together, so that's 4, and add the y's together, that's 6. So let's actually see how to implement this. Okay, so double new x. So let's figure out how to get the new x value. So remember, this is called, it's t1 plus. So this plus right here has access to only its own memory. And in its memory is mx, which is 1, and my, which is 2. So, but you need both pieces of information, and this is where we're building on our knowledge. So in my memory, I pull out what the x value should be, but I have to add to that the x value of the other one. And you see that it's passed into here. So in order to ask the other for its x value, you can just do other dot get x. And you can do y plus other dot get y. And in this way, I have taken my own x value, and I've added to that the x value of the other. And remember, this is already something that we have implemented. So these are the new x and y values. And so what I need to return, again, is a point where its x value is this new x, and its y value is the new y. So I can just go new x and new y. And in this way, I've implemented this plus logic here. And you can see that. Oh, test plus. What's wrong? Oh, oops. Yeah, that's right. Hold on. Give me just a second. The test equals logic is off, I think. Hold on. Sorry, the equals. Give me just a second. I think if I comment that out, it should work. And you don't have to worry about that. Okay, let me equals return other dot get x is equal to m underscore x and other dot get y is equal to m underscore y. That should work. Hold on. Yeah, sorry about that. So in this way, what we have done is we're going to be stopping here for a second, where the other homework, I guess, could be to implement the rest of these tests. So get distance, get norm, and we can go through that at a later point of what all of these mean. We have gone through a lot, and what we've done is we've motivated the Swerve drive here and how to break down the problem into steps. Then we've taken a deep dive into classes and objects, and where you write a class once and you can create many instances of the object. Then we've looked into the test code to see how this makes a lot more sense once you understand what an object is and a class. And then we've gone into the Translation2d object, and we have said, okay, we've started to design out the class, so its properties and its methods. And then what we've done is we've seen it in the code where we've implemented the methods for getx, getY, and test plus, and we can see that they pass. So thank you so much, and I hope that we can continue in person.